Anyway, thanks for coming. I want to just reiterate Brian's point that hopefully you went over the first couple of chapters of the Swift Apprentice book, but this will also go over all of the language features, the basics. So we're going to go pretty quickly, but I will be around for any questions at the end and throughout the conference if you need it. So Swift is a modern programming language. It was invented in it was released in 2014. It was invented a long time before that. Okay, cool, let's get going. So this is the empty playground. We're going to start by learning about, we're going to put our first code in here. So if you type after me, so type let my number :int equals 42. So this is describing a constant of type int, which is an integer, and we're assigning the number 42 to it. Quite straightforward. If you come from other programming languages, you probably roughly understand what this is meaning. A couple of lines down, let's type my number equals 10. And if we give the playground a bit of time to think about it, it gets an error here by the red dot on the left. Click on that. It says cannot assign to value. My number is a let constant. And that's because we've declared it with let, which means it's a constant and we can't change it. So the way we fix that is we change let to var, and now it changes. And on the right-hand side here, in the panel on the right, you'll see two numbers. Basically, this is telling us at each line what the outcome of that line is. So it's 42 in the first case because we've assigned 42 to my number, and then it's 10 because we've assigned 10 to my number. This is just a very good way that Playground's kind of allow you to see what's going on. So let's dive into some numeric operations now. So if you type var sum :int equals 6 plus 4, this is some simple maths here, just adding 6 and 4, we'll get 10, as we see on the right there, 10, that's what we'd expect. On the next line, do sum equals sum plus 10. So that's adding 10 to sum and assigning it back to sum. So now sum is 20, as you see on the right, as we'd expect. The next line's down, if you type sum star equals 5, we'll see we're timesing sum by 5 and assigning it back to sum. The star equals is like shorthand for doing sum equals sum times 5. And it's 100, as we'd expect. Now, if you type this, let divisor :int equals 10. And then sum divide equals divisor. So we can also use other constants in these expressions, not just actual numbers. And then sum is back to 10. But integers aren't the only type we need in Swift, of course. Another very common thing we need to use in our programs are strings to represent text. So let's create one of those. We type let name :string equals, now I'm going to put my name. Feel free to put your name or anything else you want. So this is assigning a new constant called name of type string and assigning Matt Galloway to it. And on the right there, we see Matt Galloway. Next line's down, we type let welcome message of type string equals, and then we're going to type welcome, comma, space, in quotes, plus name, plus exclamation mark. This is just showing how we can use addition as well in strings, and I'll add the things together. We drag across the bar on the right there, we'll see it. We can see the expression welcome Matt Galloway. We can also do what's known as string interpolation to make this a little bit more easy to read. So if we type let interpolated :string equals, and then in quotes, welcome, comma, and then backslash and parentheses, and inside the parentheses name, like that, to let you catch up. And that's done exactly the same thing, but it's a bit more easy to read. The whole string is in one rather than using the addition like that. You can use either, but the interpolated is just generally a bit more easy to read. So let's look at another type now. Another type you'll see quite a lot in Swift, and these are called tuples. And tuples are a way to just put multiple things together in one small package. So let's do that. Let details, and then in parentheses, string, comma, int, equals, and then in parentheses again, Matt Galloway, comma, 31. So that's my name and my age. So the type here is a tuple, which contains a string first and then an int, and we're assigning it a tuple with a string and an int. And we can use that tuple like so. So we type let details message, type string, equals, and then we're going to use some string interpolation, so inside quotes, and then the backslash and parentheses again. Details.0 is details.1 years old. So you can see now on the right there it says Matt Galloway is 31 years old. And so you use the dot 0 takes the first element of the tuple, and the dot 1 takes the second element. Swift is just like any other programming language, 0 indexed. So it starts with 0 and counts up from there. Just going to put some space in so you can see what's going on. We can also name the parts of our tuples if we'd like to. So let's see how we do that. So if we do let named details, colon, and then in the parentheses this time, name colon string, age colon int. And just like before, we'll assign to it Matt Galloway and 31. This time, when we want to access from the tuple, we do it like so. So we'll go let named details message, type string, equals, and then in the parentheses this time, some more string interpolation, named details dot name this time instead of dot 0 is named details dot age years old. So this time we're using the names we've given to it, in this case name and age. You'll see on the right there when we declared the named tuple, it's still on the right said dot 0 and dot 1. It's kind of weird the playgrounds do that. It's kind of annoying, but it does. Now, the interesting thing you'll have seen here is everywhere I've had to type like string and int, and that's kind of a bit redundant, really. If we go back to the top, var my number colon int equals 42. It's kind of like, well, we were assigning 42 to that, so why do we have to tell it it's an int? Or let name colon string equals Matt Galloway. It's a string. Why do we have to say that? Well, the good thing with Swift is we don't have to. Swift has a thing called type inference, which allows us to drop the types in a lot of places. So let's see that now. So if we go let something equals 42, it works. Nothing's broken. It's because Swift has inferred that the type of something should be an int. If you hold down the Alt key and click on something, you'll actually see, don't know if you can see that, but there it says let something colon int. So that's just a way you can just check that it has done the right thing. And we can do let something else equals Matt Galloway, and if we alt click on the something else, it's string, as we would expect, which is cool. So from now on, I won't use the types if we don't need it. So the next thing we're going to look at is if statements. If statements allow us to change the flow of our application depending on if a condition is true or false. So let's go let age equals 31. It's my age. You can put your own age if you want. And then with our first if statement, if age less than 13, and then in braces like this, print child. So if you're less than 13, I'm going to say you're a child. In my case, it hasn't printed anything out. We can tell that by if on the bottom left here, there's a little button. If you click that, it's next to the play button. It opens up the console. Any print commands, if they get executed, will appear in here. But it hasn't printed child because I'm not a child. We can expand our if statement to print out some more things if I want to see if the person's a teenager or an adult. So at the end of this statement on the closing brace line, if we put else if age less than 20 in braces, print teenager. So this is saying that if the first condition is true, we print child. If the first condition isn't true, we drop to the second condition. And then if that's true, we print teenager. And if that's not true, we just carry on. But here we want to print adult if they're not a child or a teenager. So we can use an else clause. So at the bottom there, we put else, print adult. And that's saying that if it isn't less than 13 or it's not less than 20, then we print adult. In my case, it prints out adult. We can go back and change the age to like 14 or something, and you'll see it prints out teenager, or 10, and it'll print out child eventually. It's going to go back to 31. We can also combine conditions. using Boolean logic. So if we go if age is less than 10, and then these two pipe characters, the pipe character is just left of your return key, and this means or. So if the age is less than 10 or age is greater than 60, then we'll print out that the person is at risk of flu. So that's going to say that if the age is less than 10 or the age is greater than 60, then we'll print out this. In my case, it doesn't print it out because I'm in the middle of those two ages. So next thing we're going to look at is a switch statement. A switch statement also allows us to change the control flow of our application. Let's type let number of sides equals 3. There's going to be a switch statement which prints out what type of shape this is. Is it a line, is it a triangle, is it a square, depending on the number of sides. So we'll go switch number of sides and then some braces. And if we let the playground just execute, you'll see that there's an error. We'll come on to why that error is in a second. But first of all, we're going to add in our first, what we call our case. So case 1 means that if number of sides is 1, then this code will get executed. So we'll print out, it's a line in this case. But we'll notice there's still an error. And if you look in the error at the bottom here, it says switch must be exhaustive. Consider adding a default clause. All switches in Swift must handle every single case. So number of sides is an int. So all the way from like minus a very big number to plus a very big number. It needs to handle all of those cases. We've only handled case that it's 1 at the moment. The easiest way we can handle every case that we don't handle right now is using a default clause. So for the new line under here, we put default, colon. In this case, we're just going to print unknown shape. We don't understand it. Our number of sides is 3, so it's unknown shape at the moment. But of course, we do know what three sides is. It's a triangle. So let's add that in. Case 3, print triangle. We can do case 4, print square. And in this case, it prints out a triangle, as we'd expect. So now we're going to look at ranges and loops. Ranges are very useful in Swift, in any programming language, really. They allow you to do things a number of times or like iterate through a collection of things. And Swift has a very nice syntax for ranges. So if we do let 1 to 10 equals 1 ... 10. This is what's known as a closed range. The 3 dots means it's closed. And that means that it includes 1 and 10. So this variable on its own represents the concept of 1 to 10. We also have what's known as a half open range. If you type let 1 to 9 equals 1 ... less than sign 10. In this case, this means that it includes 1, but it doesn't include 10. That's why it's half open. So these are useful, as I said, like for loops in general. So let's see how we can use that. If we type for I in 1 ... 10, and then braces, and then we'll go print I. Here we're looping through the range 1 to 10, and each time around the loop, I will be a different number. So we start at 1, then it'll go to 2, then 3, then 4, then 5, all the way up to 10. As you can see in the console here, it's printed out 1 to 10, because we're just printing out the number each time around. We can also do the same thing with what we call a while loop. So if we do var I equals 1, and then while I less than or equal to 10, braces, print I, and then importantly, I plus equals 1. So what this is doing is it's setting I to 1, and then this while loop is going to run while I is less than or equal to 10. Each time around, we'll print I and then increment I. So this will run exactly the same as the for loop, and it prints 1 to 10. So let's now have a look at arrays and dictionaries. Arrays and dictionaries are our basic collections in Swift that allow us to collect data together into one set, and they're very useful. Let's see that. So let ratings, colon, and then in square brackets, int equals, square brackets again, 5, 1, 1, 3. So this is an array of integers. The int in square brackets denotes this is an array of integers. I'm just showing you the type there. We don't have to put that in because we have type inference, but here I've just shown it so that you can see what it's like. And we're assigning an array of integers to that variable. Arrays are ordered, so the order matters here. So 5, 1, 1, 3, they are in that order. We can loop through the ratings here by going for r in ratings, print r. So just like we loop through the range, we can actually loop through the array as well. And we print them out in order, 5, 1, 1, 3. Now we're going to, these are ratings for our app, maybe. So we want to get the average rating. So we can do that with some code. So go var average equals 0.0. Now, this is the first time you've seen 0.0. Like it's a decimal number. We're using that because obviously the average might not be a whole number. So we're going to need to use what's called a double. This is a type of double. We had integers before. Now this is a double. So now we'll loop through the ratings again for r in ratings. Average plus equals, and then we'll cast the r variable to a double. Casting is just saying r is an int, but we want it to be represented as a double so that we can add it to the average number. And then after the loop, if we go average divide equals double again, ratings.count. That's just getting the count from the ratings array and saying how many values are in there. In this case, it's 4. And as you can see on the right there, it prints out 2.5. So that's the average rating for our app. Let's have a look at dictionaries now. Dictionaries allow us to map one value to another value. So we're going to go let ages, string, int inside the square brackets this time, equals Matt, 31, Bob, 24, Amy, 28. Oops. So this is a dictionary mapping a string to an int. So this maybe is like ages. There's my age is 31, Bob's age is 24, and Amy's age is 28. Dictionaries aren't ordered like arrays are. So it does, like I've assigned them in this order, Matt, Bob, Amy, but when we iterate through it, it might not come out in that order. The order doesn't matter. But say we want to get the average age. Let's see how we can do that. So if you go var average age equals 0.0, using a double again, because it might not be a whole number. And then this time, for name, age, notice here it's a tuple. When we iterate through a dictionary, we get a tuple of the two values, the key and the value. So Matt, 31, Bob, 24, Amy, 28. In ages, and then in braces, we're going to print out name is age years old. I'm going to add to the average age, plus equals, again, we have to cast the age to a double. And at the end here, we go average age, divide equals double ages.count. And out pops 27 2/3. That's the average age of those people. And you'll see it's printed out. Bob is 24 years old, Matt is 31 years old, and Amy is 28 years old. Again, you can see here that it's not in the order I put them in. As I said, dictionaries aren't ordered. And that's it for the first demo. Does anyone have any questions? Yes?
Up above in the tuple, you gave the members names.
Yep.
Can you give names to the dictionary members?
In here?
Yeah.
No.
Did everyone hear that?
Sorry.
He just wants to know if he can give names to dictionary members. I was like,
No, we're not when you're iterating through it. I mean, you are kind of giving it the name because it's like name and age here in the tuple there. So you kind of are giving it the name in the code I'm showing here. Yeah. Yeah.
Tuples are mutable?
Mutable.
Yeah.
If it's declared var, then yes, it's mutable. You can reassign to that variable. So they're not mutable in themselves, but you can assign a new tuple to it.
For example, when you did the named,
Yeah.
Could you go in and then change the value of?
No.
Okay.
Can an array have a mix of types?
Like you could put any object and then it would do that, but or any. But in general, it's kind of best to try and as much as possible not do that, as it were. Depends on your what you're using it for. But yes, anything that inherits from. We'll get onto like inheritance later in the next section. But yes, it could be.
The arrays we declare is mutable or immutable in first place? Yeah.
Sorry?
The arrays we declare is mutable or immutable, like NS array, NS mutable array, like.
So in Swift, like if the array is declared var, then yes, you can add to it and remove from it. If it's declared let, then you can't. And that's kind of the equivalent of NS array and NS mutable array, as it were.
Will you be talking about mutable stuff later?
Not particularly, but we can chat about it if you want.
Just a question. Can I change? Oh, can I change mat 31 if I declared it var?
In this dictionary?
Yeah.
Yeah. So if you declared it var, then you could then set mat to a different the key the value for mat to a different value. Yeah. For sure. Cool. Do we have time for a break, Brian, or no? Cool, let's get cracking on the second part then. So yeah, that was the language features part 1, and this is part 2. The first thing I want to talk about here is optionals. Optionals is a very important concept in Swift. We haven't got much time to go through it in huge depth, so bear with me, and I will be around to answer any questions on this. This is a relatively hard concept to get. But optionals basically allow us to represent the absence of a value. Sometimes you need to know that. Sometimes it's like, do I have a value or do I not have a value? And in some programming languages, we use what we call a sentinel value. So like 0 means no value, but that's kind of a bit like flaky. Maybe sometimes 0 is an okay value, and there is no real way to have a sentinel that makes sense. So Swift has this concept of optionals, and that allows us to represent this absence of a value. And the way I like to describe it, best to think about it, is a box. So the optional always is the box, and then either in the box is nothing, or in the box is a value. So every time you see an optional, just think of it as a box, and the box always exists, but inside the box is either nothing or something. So in this demo, we're going to see those to start with. Another thing we're going to go over in this demo is functions. And functions are very important in the language because they allow us to split the code into reusable chunks. Functions can have like many inputs and they can have many outputs in Swift, or either one or many outputs. And they kind of generally make the code more readable. You've already seen a function, and that was print. We reused the function print. Like Swift gave us this function called print that we could use over and over again. If we had to every time, like, I don't know what it would be to write the stuff to the console, every time we did that, that would be kind of annoying. So Swift gives us this function called called print, and we can make our own functions to do the same kinds of things. So let's get cracking on demo 2. If you go to the folders again, and if you look in the demo 2 area now, you have a starter project again. If you open up that, again, it should be just a blank screen. So let's just add some spaces so we can see what's going on. So let's have a look at optionals, as I said. Let's create our first optional. So var optional int colon, and then the type here is int question mark. The question mark tells us that this is an optional, and it's an optional int because int question mark. And we're going to assign it to nil to start with. So nil is meaning that this box has no value in it. After this, we can go optional int equals 42. So we can assign a value to that. And on the right there, you see it says 42, and nil in the first case. And if we print out optional int and open up the console again, remember the button on the bottom left there? Then here we see it prints out optional 42. And that's kind of it. That's what I was saying about the box. This is printing out the box. It's not printing out the value inside the box. It's printing out the box itself. So how do we get inside that box? There's a few ways we can do that. The first way is we go print optional int exclamation mark then it prints out 42. The exclamation mark says go inside the box and get me the value. But as the exclamation mark probably gives you an indication, this is generally should be used with caution. And I'll show you why. If you, on the next line, go optional int equals nil, so we're going to set it back to no value in the box, and then print out optional int exclamation mark again. This time, we get a crash. It's like a exe bad instruction. That tells us we're doing something very wrong. And if you look in the console, it says unexpectedly found nil while unwrapping an optional value. If this happened in your app, it would crash. The app would go away. So don't use the exclamation marks unless you really need to, and generally you don't need to. I just wanted to show you it as one way of doing it. So if we delete that line, the safe way to do it is if we use what's called if-let binding. So we use an if statement like we saw in the first demo, but if we type if let unwrapped equals optional int, and then braces. So what this is doing is it's saying if the optional int box contains a value, then assign that to this variable called unwrapped, and then run the code. If optional int didn't contain a value, this code wouldn't get run. So inside here, we can print out unwrapped, and in this case, optional int is nil still, so it doesn't print anything out, and it doesn't crash, which is good. If we comment out line 10 there, put two slashes before it, then it does print out 42. So that's optionals. Now let's have a look at functions, as I said we'd go over. We're going to create a very basic function, first of all. So we type func, say hello, and then parentheses, and then braces. So this is declaring a function called say hello. And inside here, we're just going to print out hello. And on the next line, we type say hello, parentheses, and we'll do this 3 times, just to show you how reusable it is. And then if we wait for it to run, in the console there, we see it prints out hello 3 times. We've used the function 3 times. But functions can also take parameters. So we can change this function to say hello to a person. So if we type func, say hello to person, and then inside the parentheses, we'll type name colon string. And this is a function which is taking one parameter. The name of the parameter is called name, and it's a type string. And here we'll go print hello, and then using string interpolation, name. So underneath this, if we type say hello to person, and I'm going to put my name in. You can obviously put your name in if you'd like. And as we see, it says hello Matt. But functions can also take many parameters. So let's see that. If we declare another function, func say hello to person, name colon string, comma, number of times, int. So what this function is going to do, it's going to say hello to the person a certain number of times. So if we do for I in 0, ... less than number of times, using a range. So it's going to include 0 up to just one less than number of times, because it's a half open range. So it's going to run this code number of times. And we'll call our other function, say hello to person, with name as the parameter, like so. So you'll see here that we've got a little warning on line 31. Might be a different line for you. And it's saying immutable value I was never used. That's because in this loop, we haven't used the variable I. In Swift, we can get rid of that warning by using an underscore. Underscore just means ignore this value. It's quite useful to do that. It just tells Swift that you don't care about that value. You just want to execute this code a number of times. And so let's now use that function. We'll do say hello to person, Matt, comma, and now we have to type number of times, and I'm going to do it 10 times. So you'll see here that I've had to put the name of the second parameter. This is like Swift. This is one of the things that Swift brought over from Objective-C. It's a very nice way of making your functions very readable. Imagine if your function had like 10 parameters. How do you know what like the 10th parameter is or the 4th parameter is? This is like saying that each parameter after the first one, you know what it is. Like if I just put 10 there and then put number of times, like what would that 10 mean? But here it's saying like say hello to person Matt, number of times 10. It's kind of like very nice flowing left to right reading. And you'll see it says hello to me 10 times. Functions can actually also return values. So let's see how that works. If we go func, add number, a:\int, b:\int, sorry, and it returns an int. The returning an int is declared by this arrow after the function, and then int. So the arrow means what's this going to return, and we're saying it's going to return an int. Inside here, we'll just do the maths. So it's let result equals a plus b. And then the way we return a value is we say return result. So let's now use that function. We'll go let sum equals add number 5 b 10. But this kind of like looks a bit weird. We see that it works, by the way. On line 41 there, on the right-hand side, it says 15. So this function has returned the value 15, as we expect, 5 plus 10. But it kind of looks a bit weird. Add number 5, b, 10. Why is it b? But inside the function, b makes sense to be the name of the parameter, like a and b. But what we can do is we can change the function to have a different name for the variable inside the function as to outside the function. So if on line 37 there, just before the b:\int, if you write toNumber space, the function now uses the name b inside the function, but outside the function uses toNumber as the second parameter name. So if on line 41 there, we change let sum equals add number, we change that to toNumber, it now works again, and it kind of reads a bit nicer. So it's let sum equals add number 5 to number 10. It's nice flowing left to right. And that's again, like I say, it's this thing that was brought over from Objective-C, and it's quite nice. So let's now go on to classes. Classes are a way for us to declare our own types. So you've seen here, you've seen ints, you've seen structs, you've seen ints, you've seen strings, you've seen tuples, you've seen doubles. But classes will allow us to create our own data types. The first one, I'm just going to create one called a class called animal. So if we go class animal, and then braces. So now we could use animal as a type anywhere we wanted to, but it doesn't really do much right now. It's just a blank type. So we're going to say that an animal has a name and an age. So inside the class, if we type let name : string, let age : int. So now every animal can have a name and an age. We'll see there's an error though. The error says class animal has no initializers. So classes, once they've got properties like this, name and age, we need to declare an initializer to set up those values. So if we declare an initializer like so init name, input name, :string, age, input age, int, and then braces. And we'll go name equals input name, and age equals input age. So here we're saying that this initializer takes a string and an int, and then we just assign that string and int to name and age respectively. We're also going to add a function to this class. I want this animal to be able to introduce itself. So if we type func introduce, and it's going to go print hello, I am name, and I am age years old. So now let's use one of these animals. Let's create one. So outside of the class here, we type let Matt equals animal, and we go name, Matt, age 30. Well, 31 I am. And then after that, we'll go Matt.introduce. So here we've created an animal, given it a name and an age, and then we've allowed it to introduce itself. And it prints out, hello, I am Matt, and I am 31 years old. We can also, once we have a class, we can subclass that. So that means we can create a new class which inherits from that original class. If you've done any programming before, you'll probably know roughly what I'm talking about. So let's do that. Let's create a class called dog. So class dog, :animal, which means that this new class inherits from animal. So now we have a new class called dog, and it has everything that animal has. We can create one with a name and an age, and it can introduce itself. So let's see that. We'll go let rover equals dog, name rover, age 6, and rover.introduce. And it will print out, hello, I am Rover, I'm 6 years old. But now let's see a thing that subclassing allows us to do. We want each animal to be able to speak. So inside the main class animal, we'll type func speak, and we'll just have an empty function there. We're going to say that an animal on its own, it doesn't know how to speak unless we know what type of animal it is. But then inside the class dog, if you go down there, we'll type override func speak. And let's just explain what that means. So we are overriding the function speak of the base class animal. We have to put the override in there. That's kind of Swift's way of making sure we're safe. Without the override, if we didn't have that in, and it saw that we were redeclaring a function called speak, it would tell us, hey, did you mean to override this? Because we might have made a typo. Maybe we didn't want to write speak. We wanted to write, I don't know, peak or something. We put an S there by mistake. Swift is telling you that you need to be explicit that you are wanting to override this. Similarly, if we did a typo and put SPEA instead of the K on, it will say, hey, you're not overriding it, so you've made a mistake. It's quite a nice thing of Swift, that. So inside the override there, we'll type print woof. And so this is now saying that dogs know how to speak. So at the end of our code, we'll type Matt.speak and rover.speak. Matt does nothing when he speaks because he's just a normal animal and doesn't know how to speak. But Rover there says woof, which is cool. So now I'm going to look at structs. Structs are like classes. They allow us to define our own types. But they have a slightly different semantics with the way we use them, which I'll explain at the end here. We're going to create a struct for a location on the Earth. So it has a latitude and a longitude. So struct location. And then in the braces, we'll do var latitude : double and var longitude : double. This time, unlike with the class, we don't have to add our own initializer. Structs, because they're kind of designed to be these lightweight things, will automatically create an initializer for you. And it basically creates an initializer which takes the parameters as the order of the properties that you create. So here there'll be an initializer created for us, which takes two doubles. The first one it'll assign to latitude, and the second one it'll assign to longitude, because they're in the order we've created them. So let's go ahead and create a location. So if we go var location A equals location, like I said, it's created as our initializer. Latitude 51.526, longitude minus 0.140. I believe that is somewhere in London. If you want to go and check it out, you can. And now we'll create another location, var location B, and we'll assign location A to it. And this is going to show us the difference between structs and classes. Let's now go ahead and change location A dot latitude. Let's change that to 0.0. So this code here is saying assign 0.0 to location A's latitude. On the next line, let's type location B dot latitude. And on the right in the bar, we'll see it prints out 51.526. But we set location B to equal location A, so why has location B's latitude not changed? And that just that explains the difference between structs and classes. Structs use what we call value semantics, which means that when you assign a struct to a variable, it's kind of like taking a copy. You can think of it as taking a copy. So here, location B is completely distinct from location A. So when you change location A's latitude, you're not changing location B's latitude. And that wraps up the demo 2. And now it's on to the lab. But does anyone have any questions so far? I know we've gone very quickly. And I'll walk around as well. Yeah.
Yeah. What's the benefit of the wrapping something in the if statement rather than just using the question mark?
You mean the exclamation mark? To unwrap? Like this one up here?
You know, with the if let statement that you have there,
Yeah.
why would you bother with that rather than just having the question mark?
So I don't remember if you remember when I was doing it, but if we don't unwrap it with the if let syntax and we just put an exclamation mark to unwrap it, if the optional int didn't contain a value, then the app crashes.
No, maybe I misspoke. I mean a question mark. Wouldn't it just not run if you had print unwrapped question mark?
What do you mean?
On line 13, if you, instead of the if let statement, if you just had print unwrapped question mark and it was nil.
Unwrapped question mark? I mean, that's not valid syntax. Maybe I could come over and explain
Okay,
it.
yeah,
It
thanks.
sounds like it's more nuanced, so
Sure.
I'll come over in a minute. Cool.
Is it a syntax that function even if it doesn't take an argument, you have to have a parenthesis?
Yes, you need to have parentheses if the function doesn't take
Okay,
it.
one another question. So line number 47. So how do I have it? Like if I have like function has 3 arguments. For the first argument, I don't think we have a input like say AB, but for the second argument we are having
This line here, 35? My 35?
41.
41.
Yeah.
Are you asking why the first parameter doesn't have a name?
Yeah.
Yeah, that's just the way it is effectively, but it's because it helps. Like it's how Swift came over from Objective-C. So it's hard to explain it without understanding how, if you haven't come from Objective-C. But it just helps the method read left to right again, like I was saying before. The first parameter should be part of the name of the function. Here, add number 5 to number 10. You don't need to name that first parameter because it's in the method name, add number. Does that make sense at all?
Yeah. Got it. Thanks.
Cool. So onto the lab now. You should have, I think it's page 31 of the conference material. It's basically a tutorial you can go through yourself, and I'll be walking around. It's quite a lot more complex, but you'll get to see how everything works in that. Hey everyone, so I'm just going to wrap it up now. Hopefully you've had some time to do the lab. Feel free to continue in your own time. I'll be around the whole conference. Please come and find me or ask me on Slack or whatever. Just grab me somehow. So what have you learned? You've learned quite a lot, to be honest. Demo 1, we went through a heck of a lot of things: variables and constants, numeric operations, strings, tuples, type inference, if statements, switch statements, ranges, loops, arrays, and dictionaries. There's a lot to cover there. Let's go quickly. Demo 2, the optionals, functions, classes, and structs. In the lab, you put it all together and had some practice. And like I say, please finish it off, go through it. It covers a lot of stuff. So where to go from here? The first thing I would suggest is the Apple Swift documentation. It's incredibly good. It explains everything. They've got a book which you can read through and learn all about Swift. They have a reference guide to the language as well if you're particularly interested in that. But of course, I'd also recommend Swift Apprentice, which is our book. The Apple documentation can be quite dry and quite boring, whereas we make it a bit more to life and allow you to do it in a hands-on tutorials way, as we're famous for. So I definitely recommend that as well. You can find me on Twitter, and of course Facebook as well. And thank you very much.